So we've looked at how to graph sine and cosine functions. Now we're going to focus on the remaining trig functions. And in this particular video, we're going to look at tangent first. Here we want to graph the graph of y equals tangent of x over 3. But first, let's look at what the graph of tangent looks like. So if I go ahead into my calculator and type in tangent of x, get rid of all this other stuff. So tangent of x, we'll zoom into the trig mode here. Notice it's kind of repetitive, but it's sort of, there's asymptotes here where the lines never cross. So it is periodic in nature, but the tangent function, and you'll see this with the secant and cosecant functions as well. The tangent function is typically going to look like this. So as you can probably predict, the dividing by 3 on the inside of the function is going to cause this to shrink horizontally. So let's just take a look at that before we start to learn how to get the asymptotes. So if we type in tangent of x over 3 and then graph those together, here you see that it is expanded horizontally. We have a longer period for each of those. I'll zoom out just so you can see. Well, that's maybe a little too far, but I hope you get the idea that these are longer periods before you reach the asymptote. So how do we figure out where those asymptotes are? Well, let's first look at tangent of x, which we've defined earlier as sine of x over cosine of x. Notice that the denominator is going to be 0 wherever cosine of x is 0, and that happens to be at pi over 2 and negative pi over 2. Those are the two locations where the unit circle will be all vertical and not horizontal. So that makes cosine of x 0 and tangent of x would be undefined. So again, those 2 points are x is equal to pi over 2 and x is equal to 3 pi over 2, or we can also say negative pi over 2 for simplicity. So then now, so that's essentially where these asymptotes are occurring. We go back to zoom 7 here. Those asymptotes are occurring at pi over 2, negative pi over 2, in intervals of pi over 2. Now, if we look at tangent of x over 3, now we're looking for where tangent of x over 3 is defined. So we want to know where cosine of x over 3 is going to be equal to 0. So instead of finding where x is equal to pi over 2 and negative pi over 2, let's figure out where x over 3 would be equal to pi over 2 and where x over 3 would equal negative pi over 2, because that's where the function is undefined. So we've got 2x equals 3 pi and 2x equals negative 3 pi if I just simply cross multiply these two proportions. So then when we solve them, we get x equals 3 pi over 2 and x equals negative 3 pi over 2. That gives me two asymptotes, which you saw in the graph of this larger function. This asymptote will be located at negative 3 pi over 2, this one at positive 3 pi over 2, and that's how you find your asymptotes of the tangent function. So again, if this was negative 3 pi over 2 and this was positive 3 pi over 2, write those in there, then we're going to have our typical tangent function that looks something like that, crossing at the point 0, 0, unless it's been shifted horizontally or vertically. So see if you can predict where the vertical asymptotes of y equals tangent of 4x would be, notice that now they're giving you the general case here. All they're doing is what we did earlier, but they're multiplying what we got times n. So if we really wanted to, we could have said our vertical asymptotes were at 3 times n, or 3 pi times n over 2. So just a reminder there that you're still figuring out where those tangent of 4x is undefined. And now see if you can graph the, or sketch the graph of y equals tangent of 4x.